Okay, so this tutorial is about milestone 2. I will talk about how you should get started for milestone 2, what you should work on during the reading week or you won't make it. So initial steps, first you download and read the handout. There's a walkthrough section in the handout that you should follow. You have the ECGL quick start guide. Hello. Yeah, so just to repeat, we are talking about milestone 2 in this tutorial, and we're going through how you should start. So you have the milestone handout. There's a walkthrough section in the handout, and there's the ECGL quick start guide. ECGL is the package that we are using to do graphics. You should be modifying main.cpp, and I'll show you how to do it. And you should implement the draw map function. So modifying your main function in the main.cpp, you should first remember to include the m2.h. And this header file, you should know where to find it. And add one more line in the function between the load map and the close map. Do call draw map in here. And let's get started with the graphics step by step. First, let's create an empty window like this. So this window is a window that has buttons and it's not drawing anything. You have title here. This should be the name of your program, so you should be modifying this. Implement draw map. Make sure to include all of the header files you need. And the ECGL headers. And these files, you should be able to find them in your repo and read those in detail. And they describe all of the features of ECGL that you are using, like draw rectangle or draw line or anything, like color or anything. And in the draw map, here is the initial setup. First, main.ui. This also is a file in your repo under libstreetmap resources main.ui. And this defines the window layout that we just saw. Window identifier and canvas and the identifier will give them main window and main canvas. Then we create the ECGL application using the settings that we just defined. Then we run the application by passing the control to ECGL. And these 4 null pointers, I will be covering them afterwards. Now, because we're creating an empty canvas that does nothing, empty window that does nothing without the canvas, we're just passing in null pointers. And after this, graphics window will open, and this run will not return until your graphics window is closed. And in the window, you have the pan buttons that can pan through the canvas, move through the canvas. You have the zoom buttons, and the proceed will allow you to close the window and continue. And I'll show you what it will look like. Let's look at the code first. So draw map minimal will draw the minimal layout of the code is not responding. Okay. This is just the same code that I just showed. Application settings and nothing else. And let's go make and run matter. So this will be what you will see. This is an empty window with nothing on it. And if you click on any of the buttons, it will select fault because we don't have a canvas. And let's go back to the presentation. Now we want to define a canvas and draw on it. How to define a canvas? We will first know where is the canvas, like which canvas are we drawing on. And in this case, it's main canvas as defined. And the coordinate system, we will use initial world to define the coordinate system of 0, 0 to 1,000, 1,000. These two are coordinates of the lowermost point and the rightmost point. Yeah. Right and top. Lower left and right top. Top right. And let's add the canvas in here. This will do the main canvas, and it will call the function draw main canvas and use the coordinate system initial world. Then in the draw main canvas, we can just draw a rectangle of 0, 0 to 1,000, 1,000. And this function has one parameter renderer, and that's called directly by EasyGL, so you don't need to worry about that. And you are just using the renderer G to call the functions to draw. And everything should be in the EasyGL graphics HPP header file. And for now, we're just drawing the rectangle, and 0, 0 and 1,000, 1,000 are the bottom left corner and top right corner. So this will be what you see, and the two corners. Let's go back to the VNC and let's this. So in the code, I'm going to draw the second draw map. Blank canvas, and it's the same code. So you have the draw map blank canvas, and within that you have the add canvas, and let's go to the draw main canvas blank, which is here. So these are just the same code. And let me save the file and go to the terminal to do the compile and run. And here is what you will see. Rectangle. This is 0, 0, and this is 1,000, 1,000. And if you see the draw main canvas blank, we have the set color to black. That is the color of the rectangle. Set line width to 10. So the width of the line, this is 10. and draw a rectangle is the same. Okay. Let's go into the next step. I want to draw the intersections of Toronto. So the first thing is to get the data structure set up and start drawing and start filling in the data structures. So in this case, we are going to use a struct intersection data with the position and name. And we're storing that in a vector of intersections. So how would you write your code to initialize the data structure intersections? Hello? You should know that from module 1, right? It's similar things. We have the vector intersections of intersection data, and intersection data contains position and name. So if you want to load in that vector, it's the same thing you did in load map from milestone 1. So write a for loop, looping through all of the intersections and getting the position names. Resize first. Okay. And after we get that data structure ready, in the draw main canvas function, we can then draw each intersection in here. In this case, we want to start with drawing rectangles for each one. So we loop through all of the intersections. We find the latitude and longitude for each one of them and setting them X and Y coordinates. And then we want to draw rectangles of width 10, height 10, and see the fill rectangle versus the draw rectangle. The draw rectangle will draw a rectangle that's not filled, and fill rectangle will draw a rectangle that is filled with color. And we do the X, Y, and X plus width, Y plus height. So in this case, the lower left corner is going to be the exact position of each intersection. And let's see what we will get. This is what we will get. And all of your intersections, your entire Toronto map is here. And why is that? We have a small pixel here. Why do we have a small pixel there, but not a large map? Yeah, because the longitude and latitude are really close together. So everything will be close together. Let's see it on the code. this and uncomment this. Then close this. So it's this. And if we zoom in, it's still a square. And the program froze. Okay. And in this case, the code should be the same as what I just showed. The filling in intersections. And after the initial, we draw on main canvas XY, and that's here. And it's just the same code. So what if we want to see the actual map? And so what should we do if we are going to use X and Y as the longitude and the latitude? What coordinate system did we set up as initial one? It's 0 to 1,000, right? 0, 0 to 1,000, 1,000. So we want to find the bounds of the map and set your initial world as the map bound. So in this case, you are first defining the max latitude, min latitude, max long, min longitude. And you want to first determine the bounds of your map. And we have two blocks of code, where the first block is how you would initialize max and min. And the second one is how you would find the max and min. How would you do that? Let's break out into teams and discuss. Yep. So we use the first one to initialize, and then in the for loop, we just do the maximum functions in STL. And after this, in the initial world, we do the max and min values instead of 0, 0 and 1,000, 1,000. Then we'll get this. And this is because For each intersection, we're setting the box to be 10 by 10. And because that is too big relative to the latitude and longitude, I will set it to 0.001. And this is the question you should be thinking about in your milestone. Should the width and height change based on the zoom level? I'm not going to show you how to do it, but this is a question that you should be thinking about. So after we set it to 0.001, this is what we will get. For Toronto. Is this the correct map for Toronto? Go on Google Maps and see what Toronto looks like. What else? Like, is this the right projection? So this, because our coordinate system is lat and long, this picture is actually stretched, right? If you do a comparison with Google Map. Yeah. Let's first do a demo to see that this is actually the case. I'll comment on this one and go to the next one. So this is the exact same code. And the draw main canvas function is getting the height and width 0.001. I'll save this file and I'll compile and run. Okay, and you can zoom in. This is what you will see. So should you be changing the square size based on the zoom level? That's the answer. And zoom fit will just zoom to fit all of the points. Let's proceed. So now, because our map is stretched due to lat long, we should be now converting lat long to Cartesian x and y coordinates to see the correct projection. And by the way, the reason why lat long is stretched horizontally is because we are in the north part of the Earth. And we're very north. So, and if we want to project that to Cartesian xy, we want to do it based on the average latitude of the map. So refer back to your milestone 1, and you will first need to find the average latitude of the map and write the functions to do the conversions to and back from lat long to xy. So you should be writing both conversions. And let's rewrite the functions from latitude and longitude to x and y by calling the helper functions. And the width, we will set it to 100 meters. Because your latitude and longitude should be converted into meters. And the other code are the same. Then do we have anything else to change? If we change latitude and longitude to x and y, do we need to also change the coordinate system as well? Let's change it to x and y from latitude lat long. And this will be the map that we are getting with the corrected projection. And these are the differences. Then I'll also show you the code in the demos. See, these are the same code that I just showed you. First, getting the max and min latitude and longitude, and getting the average latitude from the max latitude and min latitude. And initial world is x from long, y from lat of max and min latitude, longitude. And add canvas will be this one. So in this case, in our code, we're adding the chrono codes to also time it. So these are the code for drawing out the canvas and saved. And let's see. This is the map with the correct projection of Toronto. And you'll see the intersections by zooming in. And let's look at the time. Okay. And the reason why I showed you the time is because that's the next thing we're going to talk about. The draw main canvas function is speed critical because this is directly related to the response speed of your map after when you need to draw a lot of other things. So is this still efficient to do? So the draw main canvas function will be called every time your canvas is refreshed. For example, when you are zooming in, your canvas will be refreshed. When you're moving, Not necessarily. So the conversion between the Cartesian coordinates and lat long will include the call to sine and cosine functions. The cosine function. And the cosine function is slow. So it's not efficient anymore. If you need to call it every time the canvas is refreshed, and for each of the intersections. And after you draw the other things, it will be called for each feature, for each curve point of your street. So in Toronto, it's going to be over 150 million calls per redraw just for intersections, and you will get more for drawing other things. So we want faster redraws for smooth panning, ideally 10 to 100 milliseconds. I'm showing you the hint to this question, how to reduce the computation. This should be very intuitive now after you did muscle one, right? How to reduce computation. How to reduce the number of computation. Yes, you compute it first and store. So in the intersection data, we add in the new XY coordinates for each intersection and pre-compute them in load map. And in this case, I'm storing them in point 2D, which is defined by EZGL. And you can directly pass it into the EZGL functions using this fill rectangle intersections inter_id.xylog. That's a point 2D object. And then we just need to specify the width and the height. Okay. So we pre-compute them in load map, and then we just need to go into the struct and grab the point, 2D point. And let's see the demo. That was actually fast. So I'm going to go into another repo for this. So in this case, because we are storing the coordinates, so in the draw main canvas function, we are just grabbing them here. And I'm timing it as well. And just making sure I have this right thing from here. Yeah. Yeah. Okay, I'll run them side by side so that I'm not impacted by the machine speed. So we can see that draw main canvas was caught twice. And here are the times. And I'll do the same thing here. See the difference? So we went from 0065 to 0035 in the first run. And in the second run, this one was reduced by a bit. Okay. So these are the times that was obtained when this slide was made. It's slightly different from what we just saw. But usually we will have a longer time to display the whole map. And we will have a shorter time to display the map while zoomed in because the things that are off the screen are usually rendered faster. So, and this is just the concept of speed up. Getting from 0.06 to 0.003 is a 2x speed up. 0.009 to 0.006 is a 1.5x speed up. And this concept will show up later if you take some computer organization course. Now, because your map needs to be interactive, I'm going to show mouse clicks as an example. So in this case, I'm going to still only display the intersections, but I'm going to highlight them when we detect a mouse click on the intersection. So first, in the application.run, remember the 4 null pointers that were here. The second one is reserved for mouse clicks. So when you do act on mouse click here, the application will call this act on mouse click function every time it detects a mouse click. And you will have the application, the GDK event button event, and the doubles X and Y, which are the coordinates that the program detects the mouse click. And because the coordinates are never going to be the same as your actual intersection coordinate, so you will need to find the closest intersection to the mouse click to determine which intersection to highlight, right? Everything clear? Anything unclear? So after we detect the mouse click, we want to find the closest intersection to X and Y from your function from milestone 1. And because your function from milestone 1 takes in the lat long, you will need to do a reverse conversion of Cartesian to lat long. And you'll find the intersection ID and you will be highlighting that. And this code will just output the closest intersection. And then if we want to draw to highlight, we can also add in the draw fill rectangle here with the XY location and setting the color to red. So what we will get now is this. Act on mouse click will then draw the intersection in red. And just note the function calls here. We're getting the renderer G from app.getRenderer, setting the color, filling the rectangle, and flush drawing so we can actually see it. Running it and clicking. But in this case, after it's highlighted, we can highlight as many as we want. But when the zoom level is changed, it disappeared. Let's look at it again. We can highlight, but if we move or if we zoom, they will disappear. And this is because every time when draw map is called, it's not going to re-highlight these intersections. Okay. So how do we keep them even after the map is redrawn? We use states. How? We want to, so this is what EasyGL will do when it senses the mouse click. It will call the mouse click function, detect mouse event function, and in the call, which is the callback function, and write the callback function. In our last code, we were drawing the highlight in the callback function, but that will not show up in your draw map. So instead of drawing it directly in the function, we want to record the state. So your future redraws will see it and keep it highlighted. And then we want to modify the screen redraw function to also do the highlighting. How we would do it now. So here are the callback functions that are generally registered. And because we're only doing mouse click, we are only having the second one. But the other ones are these ones. And if you need to use them, this is the general form. And now let's look at the mouse click. We find the closest intersection. Then In the intersection data, we have another field called highlight. This is a Boolean, saying if it's false, then it's not highlighted. If it's true, then it is highlighted. And in the act on mouse click function, we set the highlight to true. We set the state and save it. And then in the draw main canvas, we then detect whether it's highlighted. If it is, then we draw it in red. If it's not, then we draw it in black. Make sense? And let's see what we will get now. So into the next one. This one. So everything's the same. In the draw main canvas highlight, we have these few lines added. And in the act on mouse click, we're setting the highlight to true. Let's see. Make and mapper. Zoom in and highlight some. See that nothing's showing up, but if you pan it, you will see the intersections being highlighted. And why is that? Why is that? Yeah, you're right. It's because before that we didn't call the redraw function, so the map is not redrawn. So next. When state changes, graphics will not update. We need to force redraw. We can also add information to the status bar at the bottom of the screen, not just the terminal. And here is what we can do. So we have a string stream with the information. Then we can do the app.update message string.str. This is making the string stream into a string. And this will display a message at the bottom of the screen. App.refresh drawing will force a redraw. And this is added into the act on mouse click callback function. I'll show you it now. By the way, you can get chocolate bars for just showing up. And if you participated it, you can get more. So you'll see the draw main canvas is the same one, and the act on mouse click function is now here. So we have the message at the bottom of the screen and the force redraw. And run. Zoom in and out. You'll see intersection selected and the highlight. Intersection selected and the highlight. And if we move, they still stay. Okay. Actually, another thing I want to show you. If I want to select this one, I click on this one. It's selecting the other one that's close to it. And why is that? If I want to select this one, I click on it, it's selecting this one. Why is that? Remember how we are drawing the squares? Yes, the actual intersection coordinate is at the bottom left. So if we click on the bottom left, it's selected. But if we click on the middle, it will select something that's closer. So now, select is not accurate to the user's perspective because it intuitively you will be assuming that the accurate position is at the center. So we want to now move it to the center instead of the bottom left. So what we want to do is that we want to do the intersection location. And this is getting the actual location minus it by half of the width and half of the height. And this interlock will be the lower left corner where you draw. And now the actual intersection location will be at the center. Move back to the code. It's this one. And we are using the same act on mouse click as the last one, and the draw main canvas is updated to take the center. So by changing the location of the leftmost corner, bottom left corner. And I'll save, compile it again, and run. So now, if I want to select this one, it will select this one. If I want to select this one, it's this one. Right. Another thing you might want to do in milestone 2 is to add buttons. And these are just dependent on how you choose to do the design. So I'm going to show you how to add the pinkify button, which is making the entire map to be pink. So we want to register an initial setup callback function with EasyGL, which is the first one in the 4 callback functions. And we create the function in we create the button in initial setup. So initial setup is where you create the button. And when the button is clicked, it will call our toggle pink callback function. That's another one that's registered inside initial setup, and it will toggle a pinkify global variable. And if the pinkify global variable is 2, the screen redraw callback will draw a pink background first before drawing anything else. And here is the call. Here is the code of the call. So in application.run, we now make the first null pointer into initial setup. Then in initial setup, we have the application, the Boolean new window, which is not used in this case. And we will be creating a pinkify button in the 6th row by calling application.createButton. Pinkify is the name that's showing on the button, 6th row, and it will call the toggle pink function that we just wrote. And in the toggle pink function, it accepts 2 parameters. First one is a GTK widget, which is not used in this case, and the application. Then in this one, we're just toggling the global variable pinkify, and we will force redraw. Okay, is that clear, or is that too complicated? So basically, it's just calling a loop of callback functions. And in the draw main canvas, we will be doing pinkify before everything else. So if pinkify is true, we will be drawing a pink rectangle in the entire canvas by getting the visible world, setting the color to pink, and fill rectangle of the visible world. Then after that, we will do the draw intersections and draw features, draw everything else. What you will see. So we have the draw map pinkify, and we have the initial setup, and the draw main canvas pinkify. The initial setup will just create the button pinkify, and it registers the callback function toggle pink. Then the toggle pink callback function will be toggling the Pinkify, which is the same code that I just saw. Then the draw main canvas Pinkify will first check if Pinkify draw the background. If it is, then draw everything else on top of it. Just remember, I'm doing the Pinkify before everything else, because if I do it afterwards, it will overlap with the other ones and it will override the other ones. So it will cover the other ones. So if I do the compile and run, we have this. You can zoom in and out. And we have the Pinkify button here. This will draw the entire world pink. Toggling it will just disable it. Okay. And that's it for tutorial 6. Because we only have 3 people, so it's fast.